10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Beginning pitch over. Stage 1 propulsion nominal.
The Goddess of Grain is on her way to orbit following a clean liftoff from Pad A at Launch Complex 1. And as you can see, we don't have vehicle cameras, but we are holding speeds of over 900 kilometers an hour at more than 6 kilometers in altitude above Earth, all nominal. We're coming up quickly on our first launch milestone called Max Q, or Maximum Aerodynamic Pressure. This is the moment when Electron will experience peak structural load on the way to space, and we should hear a call out shortly from Mission Control.
Cleared Max Q.
There we go. That's Max Q, cleared by Electron, now at speeds of more than 2,200 kilometers above Earth and 10 kilometers above Earth and 2,200 kilometers an hour. Sorry about that. Up next is MECO, or main engine cutoff, where we'll say goodbye to Electron's first stage and its 9 Rutherford engines once they shut down. After shutdown, the first stage will separate, making way for the second stage to take over. Powering the second stage, the single vacuum optimized Rutherford engine will soon make its debut, igniting to continue the mission. Just a reminder, we're trying to get those cameras back, but we can reassure you we are nominal at this stage.
Right, the second engine will take over on a critical task of propelling the payload towards its targeted trajectory, ensuring it reaches orbit as planned. So we should hear that call out from MECO in about 40 seconds. Let's listen in.
15 seconds to staging.
Entering burnout attack mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
And there it is, confirmation of MECO, stage separation, and a successful second stage ignition. That second stage is performing nominally while it carries QPS-SAR-13 closer to orbit at more than 7,900 kilometers per hour.
Next up will be fairing jettison. So until now, the SAR satellite has been safely enclosed within Electron's 2 protective fairing halves, keeping it secure during the initial stages of flight. Pretty soon, those fairing halves will split and fall away since QPS-SAR-13 no longer needs its protection from the friction of the lower atmosphere. We're listening out now for fairing jettison confirmed from Mission Control.
Fairing jettison confirmed.
HVP discharge holding nominal.
Stage 2 propulsion nominal.
Fairing separation confirmed, and we have those vehicle cameras back. The QPS-SAR-13 satellite is now experiencing the vacuum conditions of space for the very first time. We are now about 4 minutes into today's flight, with just under 6 minutes left in the second stage burn.
As powerful and efficient as Electron's second stage engine is, the journey to orbit is still about 3 times longer than how long it took for Electron's first stage. So to ensure the second stage has the energy it needs to go the distance, it performs a unique and critical maneuver known as battery hot swap.
That's right. Unlike traditional engines, Electron's Rutherford engines are electrically powered, which allows us to carry out this innovative process. The second stage will seamlessly transition to a fresh set of batteries mid-flight, ensuring an uninterrupted power supply and keeping the mission right on track while we drop even more unnecessary weight on our way to space. This is a capability unique to Electron and shows the advanced engineering and thought behind its design.
Yep, the process is so seamless that it can be quite easy to miss. But keep an eye on the screen for the shiny object on the right there. That battery pack will disconnect and fall away from the vehicle, and that will be our visual cue that hot swap was successful.
Guidance is nominal. 200 seconds remaining.
HVB discharge holding nominal, approaching hot swap in 30 seconds.
Throttling down.
Battery jettison confirmed.
Hot swap successful.
Hopefully you were able to catch a glimpse of those batteries falling away, as that was successful hot swap confirmed. Electron is currently traveling at a speed of 15,500 kilometers per hour at an altitude of 244 kilometers. There's approximately 2 minutes remaining in this engine burn. We've checked off the vast majority of our primary ascent milestones now and are heading into the final actions left on the second stage.
That's right. The last few milestones for Stage 2 are SECO and then stage separation of the kick stage. Practically the same as the actions that took place between the first and second stages for our first separation event, except instead of main engine cutoff, we have second engine cutoff. Once that's complete, the kick stage, with its IQPS satellite attached, will be separated into its transfer orbit for the mission. Because the kick stage is initially released in an elliptical pattern, a transfer orbit will bring the kick stage to our planned 575 kilometer apogee. That journey takes about 40 minutes or so from the moment the kick stage is separated from the second stage, and once the kick stage reaches its target, its own Curie engine will start up to perform the maneuvers needed to circularize its orbit.
But before that happens, of course, we have to make our way through SECO and kick stage separation from the second stage. That's coming up in just a few moments now, so let's go ahead and listen in for the callouts from Mission Control.
And hurry, burn out the take mode.
Guidance is in terminal. 20 seconds remaining. SECO confirmed.